We got lesson 6.3 pulled up, yes. We are looking at lesson 6.3, and while related to vectors, we're taking a slightly different route. We're going to look at something called parametric equations. The idea with parametric equations, okay, we're used to an equation just being one set equation. The idea of a parametric equation, the first example is down here, is that it's written in two pieces, okay? A parametric equation is written in two pieces in terms of there's an equation that defines x, there's an equation that defines y, and it's done so with an extra variable. That extra variable is what we call a parameter, and it helps us to define what x is and what y is. Okay, so a little bit of information up top here. The graph of the ordered pairs x comma y, where x is f of t and y is g of t, are functions defined on an interval a to b of t values, is a parametric curve. Okay. One of the parametric curves we'll look at eventually is if you think about our unit circle. On the unit circle, the x value is your cosine value. The y value is your sine value. Okay, same type of thing there. But with parametric equations, x and y are defined in other functions, and there's this t value, which is your parameter. And when you have this, it's done on a specific interval usually. The equations are called parametric equations for the curve. The extra variable t is what we call the parameter. And then the interval of a to b of t values is the parameter interval. And that defines how far we go on the equation, which will make a little bit more sense after we graph a couple of these. Okay, so we're going to spend the front side kind of looking at this parametric equation and looking at how we put a graph together for it. It's not just a scenario of, oh, hey, I know what that equation is because we've got two pieces here. So the equations we're given are x equals t squared minus 2 and y equals 3t. On part A, we're specifically going to look at this graph, or this equation, when the t values are between -3 and 1. So what we're going to do is we're going to set up an xy chart, except I'm actually going to give it 3 columns. We're going to have a t xy chart. So we're going to have a t column, an x column, and a y column. Now, our t values are provided. The interval of t values it suggests, or that it asks us to use, are between -3 and 1. Technically, every value between -3 and 1 could be considered. But when we set up our chart, we're just going to look at the integer values here. So I'm going to start with -3, and I'm going to go all the way up to 1. So -3, -2, -1, 0, and +1. And we're going to start off and we're going to find our x values. When t is -3, I want to find x. So I'm going to take my x value, or my x equation, and I'm going to put t in. So when t is -3, -3 squared minus 2. What is -3 squared minus 2? -3 squared is 9, and 9 minus 2 is 7. Okay, I'm going to keep working on my x values. So -2 squared minus 2. -2 squared is 4, minus 2 is 2. -1. -1 squared minus 2. -1 squared is 1, and 1 minus 2 is -1. 0. 0 squared minus 2? -2. And 1 squared minus 2? 1 minus 2 is -1. Okay. Repeat the process with the y values. Okay. Y equals 3t, so when t is -3, what is y? Yeah, 3 times -3, which is -9. When t is negative 2, what is y? 3 times negative 2 is negative 6. When t is negative 1, y is negative 3. When t is 0, y is 0. And lastly on this one, when t is 1, 3 times 1 is 3. Okay, so we have a set of xy values now, okay, that came from taking those t values, that parameter, and plugging them in. We're going to graph this equation now, what we have of it, and we're going to graph it by just using the xy values we just created. Okay, so we're not going to physically see the t values on the graph. They're kind of behind the scenes. But we're going to use those xy value ordered pairs to graph this and see what our equation looks like at this point. Let's see. As I set up my graph, I need to be able to go as far as 2 left and 7 right. Just trying to give you an idea. In terms of my y's, I need to be able to go as far as 9 down and 3 up. Okay, so kind of making my graph lopsided on purpose, just looking at what it is that I needed. So first ordered pair, oh wait, hold on, let me put some marks on here. 2 left, 7 right. I need to be able to go 3 up, and I need to be able to go 9 down. Okay. I didn't necessarily label my tick marks, but I like to put them on there ahead of time. It helps me to be organized here. So the ordered pair 7, negative 9. I'm going to go right 7 and down 9. The ordered pair 2, negative 6. Right 2 and down 6. Negative 1, negative 3. So left 1 and down 3. Negative 2, 0. Left 2, up or down 0. And negative 1, 3. Left 1 and up 3. What do you see? What is this creating? Can you tell? We just don't have all of it yet, do we? Okay, now, you're going to notice I'm only going to connect the dots we have. I'm not going to go past the dots because we're specifically on this parameter of negative 3 to 1. And I'm just essentially, I'm connecting them in the order we graph them. And so that's what I have right there. Notice I did not go past my points and I did not add arrows. Because my graph is, that's all I have right now. I was specific, if they didn't give us an interval, we could use arrows, we could go past. But because they gave me this interval for my parameter t, it's only with the ordered pairs associated with t being negative 3 to 1. So we have part of a sideways parabola, if you will. Okay? Are we good there? Okay. What about part B? Part B, we're still using the same equation. What happens? Yeah, my t values are a little different, aren't they? Now, do some of them overlap? Some of them overlap, but then some of them are different. So I'm going to essentially do B the same way we just did A. Again, I'm going to set up a chart with my values. So my chart's going to have 3 columns. We're going to have the t for the provided t's, an x column and y column to find the values I need. And this time, t is negative 2 to 3, so I'm using all integers in that interval. Negative 2, negative 1, 0, 1, 2, 3. Can we use some of our values from above? You can. You can also just put, the math isn't bad, is it? So you can also just put them back in. But you can also notice that up above, we had -2 through 1, didn't we? So you can use those again. Okay. So if you look up above, -2 had an ordered pair of 2, -6. -1 had an ordered pair of -1, -3. 0 had the ordered pair -2, 0. And 1 had the ordered pair -1, 3. If I plug 2 in to get my x value, remember x is defined to be t squared minus 2. So that's going to be 2 squared minus 2. 4 minus 2 is 2. If I go ahead and plug 3 in while I have the x equation in my head, 3 squared minus 2, so 9 minus 2 is 7. So those are my other two x's I need. And if we plug my y's in, what was my y equation? 3t? Yeah. So 3 times 2 is 6. 3 times 3 is 9. And again, you don't physically see the t values on the graph, other than it, defines where your graph starts and stops. But they help to define the x and y values. Okay, are you guys getting the graph set up? I think some of you are ahead of me. So let's see. With this in mind, I need to be able to go 2 left and 7 right again. And this time I need to be able to go 6 down and 9 up. Two left, 7 right, 6 down, 9 up. Okay, and graph away. 2, -6 means I'm going right 2 and down 6. -1, -3, left 1, down 3. -2, 0, left 2, up or down 0. -1, 3, so left 1, up 3. 2, 6, right 2 and up 6. 7, 9, right 7, up 9. What's my graph looking like this time? Still a sideways parabola, but different piece of it, kind of. Okay, we lose some on the bottom, but we gain some on the top, don't we? Okay. As you look at C, can you tell what C is going to do when you look at that interval? Yeah, it's going to put it all together, isn't it? Or at least from -3 to 3. Okay, so we kind of have a lopsided 2. Now it's going to put it all together. Technically, you can just go use your values from the other ones. I'm going to write my values so I have them all together. Although I'm going to be honest, I'm not going to bother finding any of my values. I'm just going to write them down because we already did all the math, right? So you're going from -3 to 3, so -3, -2, -1, 0, 1, 2, and 3. Negative 3, the ordered pair was 7, negative 9. Negative 2 was 2, negative 6. Negative 1 is negative 1, negative 3. 0 is negative 2, 0. 1 is negative 1, positive 3. 2 is 2, 6. And 3 is 7, 9. Okay, this time it's the full deal. You're going 2 left, 7 right. You've got to be able to go 9 down and 9 up. In other words, label appropriately, right? Two left, 7 right. This isn't going to work very well for me, but I'm going to make it happen. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops. Oh well. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'm starting with right 7, down 9. Right 2, down 6. Left 1, down 3. Left 2, up or down 0. Left 1, up 3. Right 2, up 6. And right 7, up 9. If done correctly, you have the entire parabola, right? Now, you'll notice on all of these, I haven't gone past my endpoints. I haven't added arrows, have I? And that's because the parameter is defining where this graph exists. And it's just from t-values of negative 3 to 3. So it does not go past those endpoints officially. Okay? I think that's something I didn't do on any of these. I don't think I did in my morning class too. Realize when you're graphing, this is still an x-axis and a y-axis, correct? Okay? It's still an x-axis and a y-axis. Your t-value, again, it doesn't show. Okay? Okay, so that's a little bit about how to deal with parametric equations in terms of graphing them. Okay? Officially, your parameter could be infinity, you know, negative infinity or positive infinity. And so you could have a graph that goes on more indefinitely than that, but this one did not. Okay? Okay. On the back side, okay, so on the front side, we spend our time looking at the graph and how it looks like because we don't have just one equation to look at. On the back side, the idea of what we're going to look at here is, okay, we have our parametric equation, so it's defined with two curves, but we're going to look at it now in terms of how can I make it just one regular equation? Okay, so like on the front side, how could I make that one regular equation so I'm not worrying about that extra variable of t, but just one regular equation? Okay, and you'll notice in the directions, we're going to talk about using substitution. You remember substitution as in substitution elimination? Okay, so the idea is I want to take these two given equations and I want to put them together. I want them to be in terms of x and y, and we're going to get rid of t. Okay? So, step 1 is going to be pick one of those two equations to solve for t. Okay? Technically, it doesn't usually matter. I'm not going to say always. Occasionally, there's, you know, one definite better way to go. But I'm going to say pick whichever one looks easier to you, but pick one of the equations to solve for t. Which one do you guys want to solve for t? The y equals? That's what I would pick. So I'm going to write my note up here. So pick an equation to solve for t. Okay, that's kind of my step one. So if we pick the y equation, y equals 2 minus t. We want to solve it for t. So how do you want to get t by itself here? Okay, subtract 2. If I subtract 2, I now have y minus 2 equals negative t. And okay, divide by a negative, or the other option is to multiply by a negative. It's a personal preference there. Okay, I know I personally am going to multiply by a negative person, but essentially what's happening? All of my signs are changing, right? So I tend to show it as multiply by negative 1. So we're going to end up with the equation. Negative t becomes positive t. Y minus 2 becomes negative y plus 2. Or 2 minus y if you prefer. Whatever makes you happy. Now, substitution. Once you take an equation and solve it for something, what do you do with it? You plug it into the other equation. So we're going to take this equation here, and we're going to substitute it into the other equation. I should have shortened that, but oh well. So over here, substitute into other equation. Okay, so my other equation is the x equation, right? So x equals 1 minus 2t. What's t? Negative y plus 2. Your job from here is to just kind of clean it up into something that you recognize. How's that? Okay, clean it up to the point where you can tell me what this is the graph of. So x equals, I would take the negative 2 and distribute. So 1 plus 2y and minus 4. Notice I did not do that 1 minus 2 outside. Okay. I can clean up again and say what? X equals 2y minus 3 if I put 1 minus 4 together. Thoughts on what we're seeing here? Okay. Can we solve for y? Okay. So if we solve for y, what are we going to do? Add 3. Can I flip my sides here too? I'm going to say 2y equals x plus 3. And then what? Divide everybody by 2. If I divide everybody by 2, what? Y equals 1/2 x plus 3/2. You could say x plus 3 all over 2. I'm not going to argue that detail. However, the other part I'm going to ask you to do right here, that is our equation, okay? But I want to know, what is this? Describe this to me. Okay, what about slope?
That's your y-intercept and your rise and run or whatever.
Okay, so we know our slope is 1/2. Our y-intercept is 3/2, and this is physically the graph of a line. You're overthinking it. You want to go more difficult, but no, it's a line, right? Okay, it's just x and y terms, so it's a line. So this is a line with slope of 1/2 and y-intercept of 3/2. And man, I wrote big today. So that's the other part I'm going to ask you guys to write down. So line with slope of 1/2 and y-intercept of 3/2. Hopefully you guys didn't write as big as I did, because I wrote really big. Okay, if I recall, we'll talk about the homework assignment tomorrow. If I recall correctly, in the homework you have to try and identify some of the graphs a little bit. Okay, so we'll finish these notes tomorrow. I'll talk about homework tomorrow and what all that entails. And then should have a little bit of work time tomorrow, I would think.